Hello, my name is Kent Rademacher, and I will be the instructor for this module. I'm currently a Senior Technical Trainer for AWS and teach architecting on AWS and system operations on AWS. In this module, you will learn about Amazon Virtual Private Cloud, or Amazon VPC. I will first introduce this service, followed by a feature review of Amazon VPC. We will then walk through an example Amazon VPC configuration utilizing the features previously discussed. Finally, we will summarize and cover next steps for further learning about Amazon VPC. The AWS Cloud offers pay-as-you-go, on-demand compute, as well as managed services, all accessible via the web. These compute resources and services must be accessible via normal IP protocols implemented with familiar network structures. Customers need to adhere to networking best practices as well as meet regulatory and organizational requirements. Amazon Virtual Private Cloud, VPC, is the networking AWS service that will meet your networking requirements. Amazon VPC allows you to create a private network within the AWS cloud that uses many of the same concepts and constructs as an on-premise network. But as we shall see later, much of the complexity of setting up a network has been abstracted without sacrificing control, security, and usability. Amazon VPC also gives you complete control of the network configuration. Customers can define normal networking configuration items such as IP address spaces, subnets, and routing tables. This allows you to control what you expose to the internet and what you isolate within the Amazon VPC. You can deploy your Amazon VPC in a way to layer security controls in the network. This includes isolating subnets, defining access control lists, and customizing routing rules. You have complete control to allow and deny both incoming and outgoing traffic. Finally, there are numerous AWS services that deploy into your Amazon VPC that then inherit and take advantage of the security that you have built into your cloud network. Amazon Virtual Private Cloud, VPC, is an AWS foundational service and integrates with numerous AWS services. For instance, Amazon Elastic Cloud Compute, EC2, instances are deployed into your Amazon VPC. Similarly, Amazon Relational Database Service, RDS, database instances deploy into your VPC where the database is protected by the structure of the network, just like your on-premise network. Understanding and implementing Amazon VPC will allow you to fully use other AWS services. Let's take a look at the features of Amazon Virtual Private Cloud, VPC. Amazon VPC builds upon the AWS global infrastructure of regions and availability zones, or AZs, and allows you to easily take advantage of the high availability provided by the AWS cloud. Amazon VPCs live within regions and can span across multiple AZs. Each AWS account can create multiple VPCs that can be used to segregate environments. A VPC defines an IP address space that is then divided by subnets. These subnets are deployed within availability zones, causing the VPC to span AZs. You can create many subnets in a VPC, though fewer is recommended to limit the complexity of the network topology, but this is totally up to you. You can configure route tables for your subnets to control the traffic between subnets and the internet. By default, all subnets within a VPC can communicate with each other. Subnets are generally classified as public or private, with public having direct access to the internet and private not having direct access to the internet. For a subnet to be public, we need to attach an internet gateway to the VPC and update the route table of the public subnet to send non-local traffic to the internet gateway. EC2 instances also need a public IP address to route to an internet gateway. Let's design an example Amazon Virtual Private Cloud that we can use to start deploying compute resources and AWS services. We'll create a network that supports high availability and uses multiple subnets. First, Since VPCs are region-based, we need to select a region. I've selected the Oregon region. Next, I'll create the VPC. I'll give it a name, Test VPC. And I'll define the IP address space for the VPC. The 10.0.0.0/16 is the classless interdomain routing format and means that I have over 65,000 IP addresses to use in the VPC. Next, I create a subnet named Subnet A1, and I have assigned an IP address space that contains 256 IP addresses. Also, I specify that this subnet will live in Availability Zone A. Next, I create another subnet called Subnet B1. Assign an IP address space, but this contains 512 IP addresses. I've added an internet gateway called Test IGW. Subnet A1 will become a public subnet where non-local traffic is routed through the internet gateway. B1 will be our private subnet that is isolated from the internet. Let's summarize what we have accomplished and review some next steps we have learned about and how to create VPCs, internet gateways, and subnets. Next steps include learning about other VPC features such as routing tables, VPC endpoints, and peering connections. Also, you can learn about deploying AWS resources into your VPC. More information is available at aws.amazon.com/VPC.